quotient property of exponents. So let's consider the quotient x to the 6th over x squared. This is the same as multiplying x by itself 6 times over x multiplied by itself twice. Now when we look at it that way, we can say common factors in the numerator and denominator, and we can cancel out 1x to 1x, 1x to 1x. So you'll notice what we have left are 4 x's in the numerator, so that would be x to the 4th. And if we make the connection to what we started with, x to the 6th over x squared, we have left x to the 4th. So looking at the mathematics of that, if we look at the same base, keep that, subtract our exponents, 6 minus 2 is 4, and thus the quotient property of exponents. So if we have y to the 3rd over y to the 3rd, I keep the same base, and I subtract my exponents, which gives me y to the 0. Now, one thing that I want to point out is we know that anything over itself, right? So if I would say 3 over 3, you would tell me that's 1 because 3 divided by 3 is 1. 4 divided by 4 is 1. Anything over itself is 1. So in this case, y to the 3rd over y to the 3rd is the same as 1. So this gives us the idea that any number raised to the 0 power has a value of 1, as I mentioned. So the quotient property, if we have the same base, a to the m over a to the n, the rule is to subtract the exponents, numerator minus the denominator. All right, so let's go one step further and say, well, what happens when the bigger number's in the bottom? So this is the same as x times x over x times x times x times x. Again, with the cancellation, we have 2 x's left, but they're in the denominator. Okay, so using our quotient property, 2 minus 4 gives me negative 2. That means x to the negative 2 is the same as 1 over x squared. So we kind of say if we have a negative exponent, I always say we flip it. Because right here, this x to the negative 2 is a fraction if we put it over a 1, not a negative 1, please excuse me. So to make anything a fraction, we put it over 1. So because this negative exponent starts in the numerator, to make it positive, we would put it in the denominator. Same idea. If I would have 3 over y to the negative 2, well, right now that y to the negative 2 is in the denominator. So I would just flip it. I would just move that y to the 2nd into the numerator, and then it becomes positive. You'll notice the 3 stayed in the numerator because it has a positive exponent of 1. All right, let's simplify some problems. I have 4 to the 8th over 4 to the 3rd. Well, 4 to the 8 minus 3 is the same as 4 to the 5th. And that's the idea, right? We just subtract the exponents. In letter B, I have 3 to the 2 minus 4, which is negative 2. Now, we don't ever want to keep a negative exponent. So, again, to make it a fraction, I put it over 1. And since this negative exponent's in the numerator, I want to put it in the denominator. So 1 over 3 squared gives me 1/9. Or 1 over 3 squared. I just simplified because I know what 3 squared is. Let's do a few more. 6 to the 8th over 6 to the 8th. Now, if you recognize that this is anything over itself is just 1, great. If not, say, well, I have the same base of 6. 8 minus 8 is 0. And anything to the 0 power is 1. Now let's switch and let's go to some variables. So I have m to the 18th over m to the 4th. You'll notice I have the same base. So base stays the same. I subtract my exponents. 18 minus 4 is m to the 14th. Final answer. 2 more with variables, x to the 5th over x to the 9th. I always subtract numerator minus denominator. So x to the 5 minus 9 is x to the negative 4th. That's the same as 1 over x to the 4th. And last but not least, y to the 9th over y to the 9th is the same as y to the 9 minus 9, which is y to the 0. Anything to the 0 power is 1.